Just a sec, let me close the door over here. Okay, so let's get started with oscillations. So you take a simple pendulum, right? And it's going to go back and forth. Now if I pull it out and then leave it, it's going to go back and forth. And that is what is an oscillation. So the displacement, right? So this is what is called the mean position. This is called the extreme position. So the distance from here to here, this I'm going to take it as positive side. This I'm going to take it as negative side. So if I were to find this location, right, the displacement from the mean position, and if you were to draw this in a graph, what you will see is, you will see a sine curve like this. Okay, so you see this is the mean position and this is the extreme position. So this is the maximum displacement. So it's called the amplitude A. Okay, this is your mean position. So this is with respect to time. So it means as time progresses, you'll be seeing the displacement changing. Okay, so that's the meaning of this. So this y-axis and this is x-axis is the time axis. This is y-axis. So the displacement. So y is the displacement. So y is written as a sine omega t. Why a sine omega t? Because a is the amplitude. Sine omega t is the sine curve. Okay. Sir, what does this a represent? Well, the a represents the amplitude. So you may have the same sine omega t, but if the amplitude increases, then the red line will represent the higher amplitude. So if I multiply with the higher amplitude, then I will get the same shape, but I'll be having a different curve like this. Okay, so you can see that's what I'm trying to show. Of course, this and this has to merge. Okay. Suppose if you start the oscillation, right? Suppose if you keep it in the center and if I give a push here, which means when time t is equal to 0, it is at mean position. So you see when time t is equal to 0, I'm at mean position. And after that, after some time, it will come to the extreme position. And then again, it will come back. It will come back to its mean position. Now it will be traveling in the negative direction, which means you see it's traveling in the negative direction. Okay. But what if I pull the pendulum and leave it from the extreme position? That means when the time t is equal to 0, listen carefully. This is what we will do, usually. When you pull the pendulum and keep it at time t is equal to 0, if you keep it at the extreme position, right? Then drawing the graph like this may not be appropriate. Why? Because when time t is equal to 0, here you are saying the mean position, you are saying that the displacement is 0. But when time t is equal to 0, time initial displacement is having extreme position. So that means this diagram will not be, this graph will not be correct. The sine curve will not work. Instead, in you have studied in your mathematics, the cos curve will look something like this. So it will start from here. It will go like this. So except for the starting point, sine curve and cos curve are almost the same. Only thing, when time t is equal to 0, it is at extreme position. So the amplitude. Everyone following this?
Yes, sir.
Yes. So sometimes you will see it as a sin omega t. Sometimes you will see it as a cos omega t. So don't get confused. So if I start it from the extreme position, I will call it as y is equal to a cos omega t, because when t is equal to 0, the displacement is amplitude. In this case, when t is equal to 0, it is at mean position. I can go and hit it over here. I can give a force, and then it will start oscillating like this. So here I should write it as y is equal to a sin omega t. So how quickly the particle is kind of, or the pendulum is kind of oscillating, right? So that means I need to calculate the velocity. You will see a lot of mathematics in this chapter. Okay, so the velocity. So this is displacement. So the velocity at a given time will be given as velocity is equal to dy by dt. But what is dy by dt? A is a constant. Sine differentiation will give me cos omega t. By chain rule, if I differentiate omega t, I'll be getting omega. Okay. Again, as I always say, you should be studying some differentiation integration in your 11th standard, but unfortunately, that's not happening in your mathematics. Okay. So for now, you just have to take it down. Somewhere else, I have given you the formulas. Differentiation of sine is cos. So differentiation of sine theta will become cos theta. And then this theta has to be differentiated with respect to t. So that means I have to do d theta by dt. And that's what we are doing here. So when I differentiate sine omega t, it will become cos omega t. And then by chain rule, when I differentiate omega t, I'll be getting omega. Okay, when I do d omega t by dt, it will become omega. So that omega is written in the front. So don't worry too much about this. Okay, as you study in your mathematics, this will become clear. For now, you can take down the notes like this. Or to make it simpler, I can say that d by dx and sin x will become cos x. Sir, why you are not writing this? Well, you can write it as dx by dx. Dx by dx will become 1. That's why you are not writing this. Similarly, differentiation of cos will be minus sin x. So I think I have given this somewhere else. So take it down. Any questions so far?
No, sir.
No, sir.
Okay, very good. Displacement velocity, what will be the next term which we will be interested in? Anybody? First we study displacement, then we study velocity, then what will be the next term? That's such a
Vectors.
Acceleration.
vectors. No, anything else?
Acceleration.
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 Yeah, very good. So the logical thing that comes after this will be acceleration. The acceleration will be differentiation of velocity, dv by dt. How much velocity is changing at a given time, which means you have to differentiate this dy by dt. So d by dt. So in place of v, I can write as dy by dt. So this in mathematics we call it as second order differentiation. Okay. So if you differentiate displacement 2 times, I'll be getting acceleration. So if I differentiate this one, I'll be getting a omega cos omega t differentiation will be minus sin omega t. But by chain rule, when I differentiate omega t, I'll be getting one more omega in the front. So I already have a omega, and then when I differentiate this, I'll be getting another omega. So I'll be getting omega squared. So this is mathematics. So if you don't understand it, don't worry too much about it. Okay, just take it down and study it. Okay, for your derivations. Now listen carefully. What is A sin omega t? Anybody? Look at the screen and tell me what is A sin omega t. Is that such a difficult question?
Displacement.
Displacement. Y, which means A sin omega t, I'm going to replace it with Y. So this we have an extremely important significance for this equation. Okay. So it's called acceleration is proportional to the displacement, but then it is negative here. Okay. And the proportionality constant happens to be omega square. But you know that omega is 2 pi by t. What is the meaning of this? Okay, listen carefully, very, very important and very, very, very easy. When I take a pendulum like this, and if I pull the pendulum on the positive displacement, the moment I leave this pendulum, right, is it going to go this way or is it going to go this way? Towards the left or towards the right?
Left.
Left.
Which means when the displacement is positive, the force acting on it is negative. Okay, it's in the negative direction. So this is not correct. So take it down here. When displacement is positive, force acting on the pendulum is towards left, or you can say negative direction. But what is force? F is equal to
Mass into acceleration.
ma. Yeah, mass into acceleration. Mass does not have any direction, which means force and acceleration will have the same direction. Okay. So what this means is acceleration. So acceleration will be in negative direction. Okay. Similarly, when I pull the pendulum this side, the displacement is negative. Whereas the moment I leave it, it's going to come back like this. So acceleration is towards positive direction. So this is what this represents. So acceleration is proportional to negative of displacement. Okay, very important understanding here. Not only that, if I keep the pendulum over, if I keep the pendulum here, or if I keep the pendulum here, which one will experience more force to come back? One or two? Here, this is going to come back with less velocity. This will be coming back with higher velocity, which means as displacement increases, acceleration also increases. So this is what this equation represents. Any questions?
No, sir.
So this equation which we derived, this we call it as characteristic equation of simple harmonic motion. So we have a special type of oscillatory motion called simple harmonic motion. Okay. So whenever you see an acceleration which is in this pattern, then it's called simple harmonic motion. Okay. Let's say let's say a bus is going back and forth, okay, between Tirupur and Coimbatore. Okay, maybe I don't know the center point, something like Avinashi or something. So it's kind of going back and forth. So as it goes here, right, it's not going to have higher acceleration. As it comes closer here, it's not going to have higher acceleration. So it's kind of going back and forth. Okay, so not all the back and forth or to and fro motions are simple harmonic motion. So I can just walk between A and B. So as I keep walking back and forth, it is also considered as oscillatory motion, but then it is not a simple harmonic motion. Everyone following? Only if it follows this equation, as the displacement increases, acceleration should also increase, and it should be in the opposite direction. Okay. Only if this condition is satisfied, it's called simple harmonic motion. To and fro motions. But not all of them are simple harmonic motion. Only if it satisfies A is equal to minus omega squared y, or you can say A is proportional to minus y, then it is called simple harmonic motion. It's just a type of oscillatory motion, special case of an oscillatory motion as such. Everyone following? Any doubts? Ashwant following?
Yes.
Okay. Ankita
Yes, sir.
following?
Following.
Okay. So take down the notes properly. Okay. As I always been telling you, some of the points I may not have given it in the handbook. Okay. Only if you take down all the notes, it will make sense. Okay. Need to get some water. Just a sec. Okay, let's see. What else can I talk about here? So let us go back to the equations one more time. So y is equal to a sine omega t. Velocity is equal to a omega cos omega t. This can also be written as v naught cos omega t. What do you mean by that? This is your velocity maximum. Maximum velocity. So I told you many times, whatever is in front of sine or cos, right? That is your maximum value. So here it is a maximum displacement called as amplitude. Here it's going to be maximum velocity, right? Acceleration maximum sine omega t. Okay. So the graph for the displacement will look something like this. The graph for the velocity, you see it's a cos omega t. So cos means you know that it will start from here. That means the velocity at the central when time t is equal to 0 is going to be maximum. And as the pendulum is going upwards from here, the velocity keeps decreasing. So since the velocity is decreasing, so divide it as 4 different sections. So this is pi by 2, 90 degree, 0, pi by 2, pi, 3 pi by 2, 2 pi. So mark the same points over here. So from your trigonometry knowledge, you should know that this is sine curve. This maximum value is your amplitude. So when the pendulum comes to the extreme position, right, amplitude position, what happens to the velocity? Anybody? When it comes here, what happens to the velocity?
0.
0. Very good. So that means it goes something like this. So here it is maximum, here it is 0. So that means the curve will look something like this. But after that, it is not going to come back in the positive direction. It is going in this direction, negative direction, which means the velocity will go something like this. And then again, it will come back like this and it will stop here. So this is your V max here. So this maximum value. This is also V max, but it is in the opposite direction, right? So you see, when the pendulum is going this way, the velocity is negative. When the pendulum is going this way, velocity is positive. That means you may have the velocity maximum in positive and negative. Next curve will be the acceleration. So drawing the acceleration is easy because draw the same 4 parts. You see, this is minus of sin omega t. So minus of sin omega t means opposite of this. When this is rising, this will be dropping. When this is dropping, this will be rising. So that means this will be your A maximum. Okay, here I call it as A naught. Okay, if you want, you can write as A naught or B naught. Any questions around following the mathematics and the graphs? Are you able to see the relationship? Yes, no?
Yes.
Okay. I have one more simple formula for this one, for velocity. If I take the A inside the square root, it will become A square. A sin omega t is nothing but displacement, which means I can write this as A square minus Y square. Any questions? So very often you should be knowing this formula. So in the mean position, right, displacement is equal to 0. Which means the velocity will be maximum. Why? This will become 0. So V is equal to omega root of A squared minus 0. Omega into A. And this is what we said, it is the maximum velocity. So the maximum velocity will appear in the mean position. Similarly, if I keep the pendulum the extreme position, if I consider it at the extreme position, can anyone tell me the velocity at this extreme position?
0.
0. Very good. So what is the displacement here? Amplitude A. That means V is equal to omega A squared minus Y squared has to be written as omega A squared minus A squared. Hence it will become 0. So it means velocity at the extreme position is 0. Any questions? So what I have done here is simple mathematics. So I am just trying to show you all the steps so that you don't miss anything. So instead of writing it as A omega cos omega t, you can write it as in this formula. So this is also an extremely important formula. So very often you'll be making use of this for conceptual explanation like this. Anybody still copying? Can I change the screen?
Yes, sir.
So there is a very, very important connection between circular motion and oscillatory motion. So take it down. So this is extremely important. Okay, even in your 12th standard, you will get a lot of understanding. Conceptual understanding has to be done using this basic thing. So imagine that this is like a disk. Okay. So when I am spinning this disk, and let's say I have a screen over here. Let's say I'm throwing some light over there, something like a strong beam of light. So this projection over here is going to show some shadow. Okay. As this spins over here, right? Listen carefully. As this spins over here, this will be coming to some position here. At that time, the shadow of this protrusion is going to be somewhere here. By protrusion, I mean some kind of, something which is protruding out, something like a pencil or pen. So when the shadow is, when the object is here, the shadow is going to be here. When the object comes over here, again, the shadow is going to be here. So that means by the time this completes one full circle, this would have gone from, so this is 1, 2, 3, 4. So for 1, the shadow will be here. For 2, it will be here. For 3, it will be here. For 4, again, it will be here. And suppose if I come back to this point, 5. For 5, again, it will be here. So that means you are starting from here, you are going and then coming back here. So when this completes one full circle, right, this would have completed one full cycle. Everyone following? So what you see in the screen is not a circular motion, you are seeing a oscillatory motion. So you'll see it's kind of going back and forth, and it will be a simple harmonic motion. So here it is circular motion. And here it is oscillatory motion. This is the reason why you are getting, why we are representing the oscillatory motion, something like this, because in a circle also you'll be getting something like sine omega t. In oscillatory motion, you will also get sine omega t. Sir, where did this sine omega t come from? Well, somewhere in your trigonometry in the very first theory, right? You must have studied something like this. And the object is here, right? I think it's called unit circle or something. I don't remember exactly. So I think you will study this in mathematics as unit circle. So meaning the radius is 1. So at this point, the displacement is 0. When the object comes over here, the displacement will be like this. So this will be your theta. Okay. And this will be your displacement y. But you see, this is opposite of this triangle, which means you'll be getting it as y is equal to, this is a unit circle, which means this is your hypotenuse. Okay, so we'll be getting y sine omega t. Sine theta. If this entire thing is radius r, in your maths they would have taken it as unit circle, okay, meaning it is 1. But if you want, you can take it as r, which means I'll be getting, or since we are taking it as amplitude, this will be taken as amplitude here.
S and theta.
Say that again, I can't hear you.
I just said S and theta, sir.
A sine theta, okay, very good. Can anyone tell me how did this theta become omega t here?
Sir, actually, we know that delta theta by delta t or theta by t is nothing but omega. So theta is equal to omega t.
Okay, very good. So that means velocity is equal to distance by time. So angular velocity omega is nothing but angular displacement by time. So we are not talking about linear displacement, we are talking about angular displacement. So that means theta is equal to omega into t. Okay, so this is coming from your trigonometry basics. So now you should get an idea why I got y is equal to a sine omega t. Everyone, if you are wondering, sir, well, why did you write as y is equal to a sine omega t? It is because of this reason. And you can see a very good connection between the circular motion and the oscillatory motion. And if I want to find this length, I would take it as cos omega t because adjacent side. Okay, so as I told you, you can either write it as sine omega t or cos omega t, a sine omega t or a cos omega t. You will get the same answers. Only thing, the starting point will be different. Any questions so far? Okay.
No, sir.
Okay, let's see. In the pendulum case, right? So we said the velocity here is 0. The velocity here is V max. Okay. Displacement in the extreme position will be equal to amplitude, right? Displacement here will be equal to 0. So if I say velocity is 0, you know that kinetic energy is also 0 because half mv square. If I consider this position here, right, this is the lowermost position. So at this point, this position, potential energy will be 0, something like your ground floor. Okay. So when you drop it from a higher altitude, the potential energy is there because of the height, but then that potential energy is getting converted to kinetic energy as it comes down. Okay, so that means we say that the potential energy here will be maximum and the kinetic energy here will be maximum. Why? You see, we said velocity is maximum here. If I say velocity is maximum here, kinetic energy will be maximum here. Velocity is 0 here, kinetic energy is 0, which means potential energy, the height is maximum here. Which means the potential energy will be maximum. So if I want to draw a graph for this, the way I would draw this is, this is your extreme positions, this is your mean position. So at mean position, what did we say? Potential energy is 0. Okay. Whereas in the extreme position, what did we say? The potential energy will be maximum. So the curve will look something like this. It will be something like a parabola. Kinetic energy, what did we say? I'm going to use a different color. So kinetic energy at the extreme position will be 0. Mean position, we said it will be maximum. So it means the kinetic energy will look something like a inverted parabola. Okay. And suppose if I keep adding the kinetic energy and potential energy at each point, you see here it is 0. So the red one is the kinetic energy. The yellow one is the potential energy. So the green one, I'm going to draw a straight line.
So the sum of the potential energy and the kinetic energy is constant.
Yeah, very good. So if I keep adding the kinetic energy and potential energy at each point, right? What you will see is you will be getting a straight line like this. Why? Because this is your total energy. Okay. So suppose if I come to this point, the kinetic energy will be half, potential energy will be half. So if I add them, I'll be getting the same value. So potential energy, somewhere you have studied this in the spring chapter, right? Half K amplitude square y square. I think you must have studied as half K x square, right? Your handbook, if you go to page number.
Yes, sir, we studied as half kx square.
Your volume is very low, Chaitanya. Can you say that loudly?
Actually, we studied that as half kx square, sir.
Kx square, yeah. So we called it as kx square. Okay, here we are calling it as y. Both are exactly the same thing, displacements. Instead of pendulum, right? You can consider a spring here. If I keep a mass over here and if I oscillate it, okay, we have some of these experiments in the lab. Okay, so 12 students, today they started coming to the center. For you folks, most of you are not coming to the center. Okay, even if I call you, I see Ashwant, Ankita, only 2 or 3 are coming. Okay, I don't know what happened to Kirtan and Roshni, Siddharth, Veer. All these people used to come. They stopped coming. So I think mostly your exams will be fast approaching, I think, right? Maybe around end of February, is that correct?
Yes,
Final
sir.
exam,
So mine is in March.
March. Okay. March starting, first week.
It's on March 10th, sir, I think.
Okay.
And mine is also on March.
March. Okay. Has it been
Our exams are starting on 21st, sir.
21st February? Okay. So we
So
don't
for
have
me,
much time. Yeah,
16th.
15th, February 15th. Feb
February
15th?
16th.
Okay. Okay.
So for us, it's Feb 18th, sir.
Feb 18th. Okay. I'm kind of wondering, did they complete all the portions or did they skip some of the chapters? So only if you tell me something, I can take the, important chapters first because we don't have much time.
So they have omitted few portions, sir, and they have taken out few portions from our first term and second term.
Okay. So what about oscillations? It is there or not?
We have a very little part, sir.
Okay. What about others? Oscillations is there or not? Everyone?
Says there.
For me, it's there, sir.
Okay, very good. So I think most of you are saying oscillations is there. Anybody who says oscillations not there for your school exams? That's what I thought because oscillations is required for your 12th standard. So maybe most of the schools will keep the oscillations. There may be some schools who skip thermodynamics and kinetic theory of gases. Okay. So all of you just send me a message. Okay. So I will get an idea, or you can tell me right now. So any schools which skip thermodynamics and kinetic theory? No one?
So we have thermodynamics, sir.
Thermodynamics is there. Okay. What about kinetic theory?
We have both, sir.
Both.
We are both same everything, sir.
Okay. I'm just wondering, did you already complete all the portions in school? I'm just wondering how. No.
For me, they have started with oscillations. We are expecting to complete it in 3 days.
Okay. Okay. So as I always say, let us first focus on the theory and then come back to the numericals. I'm sure you will have numericals for your exams, but without learning the theory, you cannot even attempt the numericals. And another thing, as I always say, the textbook is going to be extremely vast. Okay, so have proper notes, and of course, your handbook will also be very helpful. Okay, so most of the points, some 80%, 80-90% will be covered. Okay, so maybe here and there 1 or 2 points might be missing. Okay, so my suggestion is before your exam, then and there, keep studying your class notes and the handbook thoroughly. Okay, before even you go into the textbook. Okay, so let's continue with this. So in the spring chapter, in the work power energy chapter 6, we studied a formula called energy stored in the spring, which is potential energy, is equal to half kx square. So x is what is your displacement here. Okay. So if I compress more energy will be stored. If I compress less energy will be stored. So K is your spring constant. You see, this is also oscillation back and forth, and it will be simple harmonic motion. This is also back and forth. Okay. So instead of spring constant, of course, you don't have a spring here, but then you can still call it as force constant. So another name for this is force constant. So it means it's not only applicable for springs. You can apply this formula for pendulums also. Okay. When I pull it farther, the potential energy will be more. If I pull it less distance, then the potential energy will be less.
I wanted to calculate that MGH for the spring rate, sir.
MGH. You see, that's a good question. So potential energy means immediately the thing which comes to your mind is MGH. But remember, we are not talking about gravitational potential energy. We are talking about elastic potential energy. Do you agree? When you pull a rubber band, will you calculate how much distance you are pulling the rubber band, or will you calculate, how high the rubber band is kept from the ground? Which one will you focus on? Anybody else? Chaitanya, I'm asking you.
How we can pull, sir?
You will focus on how much you are pulling, right? That is what determines the elastic potential energy, not the height from the ground. The height from the ground will determine the gravitational potential energy. Good question though, so take it down. We are talking about elastic potential energy, not gravitational potential energy. So it means potential energy I'm going to write as half k y square. Can anyone tell me why did I say this shape will be parabola? Nobody knows mathematics. So whenever you have x square, right, quadratic equation, what does that mean? When you plot it in your 10th standard, I think you had some graphical questions. Yeah. So whenever you have h squared plus 5ax plus 4, something like that, right? It's a quadratic equation. When you plot it, you will be getting a parabola. Okay. So that's the connection between this and this. So in the equation, you would call it as quadratic equation. In the graph, you would call it as a parabola. Kinetic energy, it will be half mv square. But in your mathematics, you must have studied that inverted parabola means you will be getting minus the same. But remember, we are not talking about the y here. We have v squared here. Just now we studied a formula, v is equal to omega a squared minus y squared. Okay, this is what we derived. So I'm going to apply this. So v squared, v is equal to omega root of a squared minus y squared. Now, can anyone tell me why you get an inverted parabola instead of a straight parabola or erect parabola? Minus, very good. So that means in your mathematics, you must have studied that whenever you get a minus x square, right, it will be an inverted parabola. So in entrance exam questions, you will be getting a lot of questions based on these concepts. Here it was positive y squared. That's why you got a the erect parabola. Okay. Any questions so far?
No, sir. No.
Somewhere later on, we are going to study omega is equal to square root of k by m. Okay, so just hold on for this thought. So which means to say that omega squared is equal to k by m. So k is equal to m omega square, which means I can write this as half m omega squared y squared plus half m omega squared a squared minus half m omega squared y squared. What does this tell you? This is the total energy. So you see the total energy is a constant. It's not dependent upon y. So no matter where the pendulum is, right? So listen carefully. Whether the pendulum is here or here or here or here, it doesn't depend upon the y location. So this is the y location. So it doesn't matter where it is. The total energy is always a constant. So what is the meaning of this? Total energy is independent of y. What is y? We are talking about the displacement location. So mass is a constant. Omega is the angular velocity. That is also a constant. And amplitude is also a constant. Okay. Or we're assuming something called undamped oscillation. So the amplitude will be constant. So what I said in the graph, we are proving it in the mathematical equations. Anyone following? Any doubts?
No, sir.
Okay. Mithun Parthiban, are you following everything?
Yes, sir.
Padmaja?
Yes, sir.
Okay. So I hope you are copying everything. Okay. So if you write all the steps, it will become very, very easy. So there is one more extension for this equation. Excuse me. Just Omega, I told you 2 pi by t. Why? Because theta by time. One by t can be written as frequency, 2 pi into frequency. So omega squared can be written as 2 pi nu the whole square. Okay, you see, you have to write the nu properly. Okay, otherwise it will be confusing. So take it down properly. Nu, write it properly. So in Greek letters, this is mu. This is nu. Okay, so very often I have seen students confusing this. Mu is for microns, micro. Nu is for frequency. Side notes or side notes, keep it separately. So 2 and 2 will cancel. So the remaining 2 pi squared m nu squared a squared. So that's another expression. So somewhere in your 12th standard, very often you will be using this. Okay. So you'll see that the energy is proportional to the amplitude square or frequency square. Okay, so I think I covered all the things about total energy. And one more thing I forgot to show you here is I showed the, you see this is position, right? So the location. The same graph, you can draw it in terms of time. Okay, so omega t. So you see, how can I draw this? Potential energy will be half k y squared, half m v square. K is, sorry, y is a sine omega t. A sine omega t the whole square plus half m. Velocity is, I told you, a omega cos omega t, right? So you can call it as v naught cos omega t the whole square, maximum velocity. Half k a squared sine squared omega t, half m v naught square cos squared omega t. Okay, what does this mean? You see, the potential energy depends upon sine squared curve. Kinetic energy depends upon cos squared curve. So what does that even mean? It means that if you draw, you see, this is with respect to time. Okay, so what I was showing earlier was with respect to y displacement. So this is with respect to displacement or location. Same thing I can convert it in terms of time. So if I draw the graph with respect to time, potential energy will be starting as sine curve. So it will be like 0, it will go like this. You see, this is not sine curve, it's sine squared curve. So since it is sine squared curve, right? The square, will you have any negative values or not? That's such a difficult question. Whenever you square something, right, it will always be positive, which means you are going to have only positive values. You are not going to get anything negative, which means to say that the potential energy cannot be negative. Coming back to this kinetic energy, so look at this. So the mean position, the kinetic energy will be maximum. So that means it will be starting somewhere from here. So that means this is your kinetic energy. This is your potential energy. Why? Because for sine you have to start from 0. For cos you have to start from the maximum point. Okay. So cos squared will also become something like a curve like this. Okay, which means everything will be positive. So you will not have below the mean position. Any question? Are you able to appreciate the link between the graph and the equations, mathematics? Yes, no? Nobody understands it?
Understand, sir.
Understand? Okay. Okay, it's already 8:40. Let me quickly do. As I always say, I may not have given you all the steps in the handbook. Okay. The handbook every year I keep on improving it, right? So maybe I have to improve it a little more. Okay, all these steps are not shown properly in the handbook. So particularly this one is missing. Okay. So let's see. So if you have your handbook, right? So what I have completed today is I completed this one, displacement, velocity, and acceleration, right? I completed all these things, characteristic equation of SHM, right? SHM has a circular motion. The diagram is not shown correctly, so maybe I have to improve this diagram. And then we talked about the total energy. Yeah. So this one I will discuss it in the next class, in the integration concepts. So I think only up to this point you have for the exams. Okay, these things are not there for you. Maybe it is there, some of them are there. So all these things are given for the entrance exam preparation. Okay, so you don't have to study all of them. Okay, thank you all. If you have any doubts, stay back. Otherwise, you are free to go. Thanks. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yes, sir.
Thank you.